Hello everyone, welcome to my channel Learn and Inspire. So in this video we shall discuss about class 10 chapter 3 polynomials. Okay, so in the previous class we discussed exercise 3.1 of a few problems, and now in this video we discuss about the geometrical meaning of zeros of a polynomial. Okay, so what is the meaning of zeros of a polynomial? So as we have discussed in the introduction, what is a zero of the polynomial? Suppose if k is any real number, suppose if k is any real number and p of x is a polynomial, okay, and if p of k is equals to 0, if p of k is equals to 0, then the value of k is said to be a zero of a polynomial. Understood? P of x is a polynomial and where k is any real number, and if p of k is equals to 0, then the value of k represents a zero of a polynomial. Understood? Now let us see the graphical representation of linear polynomial, quadratic polynomial and cubic polynomial. So we have three methods. One is linear polynomial, second one is quadratic polynomial, and the third one is cubic polynomial. So as we know, what are linear polynomial, what are quadratic polynomial, and what are cubic polynomials. So linear polynomials are nothing but the polynomial with a degree 1. The polynomial with a degree 1 is called a linear polynomial. The polynomial with a degree 2 is called a quadratic polynomial, and the polynomial with a degree 3 is called a cubic polynomial. Now we discuss the graphical representation of linear polynomial, quadratic polynomial and cubic polynomial. So first we discuss about the graphical representation of linear polynomial. Okay, first topic we discuss about the graphical representation of linear polynomial. So before representing a graph of linear polynomial, so we have to know what is the general form of a linear polynomial. So what is the general form? So ax plus b is the general form of a linear polynomial with variable x. So here in this polynomial we have only one variable, that is x, and where a and b are real numbers, ax plus b is a linear polynomial where a is not equals to 0, where a is not equals to 0. So this is the general form of a linear polynomial. So in this polynomial the highest degree is 1. Okay, if the degree is 1, then it is a linear polynomial. So from this polynomial we can represent a graph. Okay, now let us see the first question, how to represent a graph of linear polynomial. So here is the first question. Draw the graph of y is equals to 2x plus 3. So in this polynomial, so we have to substitute the values of x, and from that we can find the values of y. So after finding the value of y, then we need a coordinate points of x and y. From that we can plot in the graph sheet. Okay, so first I write x, y, x comma y. Okay, so what are the values of x I take? So I take a 0, 1, 2. Okay, so now if I substitute the values of x is equals to 0, 1, 2, from that we can find the values of y. Okay, first one, put x is equals to 0, so then we get y is equals to 2 into 0 plus 3. So this is the polynomial y is equals to 2x plus 3. Y is equals to 2 into 0, in place of x we are substituting 0 plus 3. Then y is equals to 2 into 0 is 0 plus 3. Y is equals to 3. So if I substitute x is equals to 0, then the value of y is 3. So I write here 3. Now what are the coordinates of x comma y? So x comma y are 0 comma 3. Now I substitute put x is equals to 1. Then we get y is equals to 2 into 1 plus 3. y is equals to 2 ones are 2 plus 3, y is equals to 5. If I substitute x is equals to 1, then we get y as a 5. So I write y 5. Then what are the coordinates? 1 comma 5. Now I substitute x is equals to 2, then we get y is equals to 2 into 2 plus 3, y equals to 2 2s are 4 plus 3, y is equals to 7. Now what are the coordinate points? 2 comma 7. So these are the coordinate points. So the first one is 0 comma 3, second one 1 comma 5, 2 comma 7. So these three coordinate points I just plot in the graph sheet, then we can see what we get in the graph. Okay, so from the given coordinate points we can plot in the graph paper. So you can see the horizontal line we represent as x-axis, and the vertical line we represent as y-axis. The intersecting of x-axis and y-axis we represent as a origin, that is 0. Okay, so here are the coordinate points x comma y. So first 0 represents x coordinate and 3 represents y coordinate. So we have to represent 0 comma 3. So 0 x coordinate. So here are the x coordinates. So 1 2 3 positive numbers, 0 and also the negative numbers. So all these represents x coordinates, and the vertical line, so you can see y axis, all these numbers we represent as a y coordinate. So first, what is the first coordinate? 0 comma 3. So 0 is in x coordinate, so here is 0, and 3 is in y coordinate. So y coordinate is vertical line 0 comma 3. So here is 3, so here I represent 0 comma 3. Okay, so next coordinate point 1 comma 5. So 1 is in x coordinate, so here is 1 which is x coordinate, and 5 is in y coordinate. So you can see exact 5 here. Okay, 1 comma 5. Next one is 2 comma 7. So 2 is in x coordinate, so here is a 2 which is x coordinate, and 7 is a y coordinate. Here comes a 7, so I represent this as 2 comma 7. Now I join all these three coordinate points. So let me see if I join, so what we get. So if I join all these 3 points, so here we got a straight line. So from this, what can we conclude? A linear polynomial 2x plus 3. So 2x plus 3 is in the form of ax plus b, which is the general form of a linear polynomial. So the graph of y is equals to ax plus b, which is nothing but a linear polynomial, is a straight line. So always remember, a linear polynomial always represent a straight line. And you can identify one more thing. So it represents a straight line which is intersecting the x-axis. So you can see this straight line is intersecting at x-axis at one certain point. So you can see, so this line is touching at x-axis at one point in between -1 and -2, and this value is nothing but a 0 of the given polynomial. So this value represents the 0 of the polynomial. So what is this value in between -1 and -2? So this value represents the 0 of the polynomial. Understood how to represent the graphical form by using linear polynomial? So we'll see one more question. From that you can understand how to plot the given points in the graph. Remember one more point. So here we have scale on x-axis. We are taking 1 unit as a 1 centimeter, and also y-axis 1 unit as a 1 centimeter. So this is very important to represent. Okay, how we are representing on graph. Understood? So we'll see the next question. So here is the second one. Draw the graph of y is equals to 2x minus 5. So first we need to take the values of x. From that we can find the values of y. So I take x, y, and the coordinates of x comma y. So what are the values to be taken as x? So I take 0, 1, 2. Okay, so first I substitute, put x is equals to 0, then y is equals to 2 into 0 minus 5. So in place of x I am substituting 0, then y is equals to 2 into 0 is 0 minus 5. 0 minus 5 is minus 5. The value of y is minus 5. So I write minus 5 here. Now what are the coordinate points? 0 and minus 5. Now I substitute put x is equals to 1. Then y is equals to 2 into 1 minus 5. I get y is equals to 2 ones are 2 minus 5. Y is equals to 2 minus 5 is minus 3. So I write minus 3. So what are the coordinate points? 1 comma minus 3. Now I substitute put x is equals to 2. Then y is equals to 2 into 2 minus 5. Then we get y is equals to 2 2s are 4 minus 5. So y is equals to minus 1. Value of y is minus 1. Coordinate points are 2 comma minus 1. So if you want, you can take the values of minus 1 minus 2 as your wish. Okay, so here are the coordinate points. From this we can represent in the graph by using these coordinate points. Now we represent the coordinate points in the given graph sheet. So first one is 0 comma minus 5. So 0 is nothing but x coordinate and minus 5 is y coordinate. So 0 is in x coordinate, minus 5 is y coordinate. So y minus 5 comes down, so here is minus 5. So I represent here as 0 comma minus 5. Second one, 1 minus 3. 1 is x coordinate, minus 3 is a y coordinate. So 1 is in x coordinate, so here comes a x coordinate 1 minus 3 comes down, so which is a y coordinate. So here is minus 3. So I write here as 1 minus 3. And the next coordinate is 2 comma minus 1. 2 is x coordinate and minus 1 is y coordinate. So 2 is x coordinate, so here is 2 minus 1 comes down, so here is minus 1. I represent here 2 comma minus 1. Now I have joined all these points. If we join all these points, so here we get a straight line and which intersects the x. This line is intersecting at a point, okay, which is x-axis, and this exactly one point represents the 0 of the polynomial. So the line which intersect at x-axis, and that point we represent as a 0 of the polynomial. So this is nothing but 0 of a polynomial. Okay, so if I substitute this value in the given polynomial, we get a 0. Understood how to represent the given coordinate points in the graph? So this is a graphical representation of linear polynomial. So I hope you guys have understood these problems. So in the next video, so we can discuss the graphical representation of a quadratic polynomial. Okay, thanks for watching.